Hello, ladies and gentlemen. Today we have pre-calc lesson 43, periodic functions and graph of sine theta and cosine theta. So the three most important function types that we've learned so far, we have linear. So if this is our x, y, it could be this line, which is y equals x. It could be, we've also talked about quadratics. Again, this is x and y. This is the graph y equals x squared, or exponentials. Y equals e to the x, right? Or y equals, let's say, 1 to the x. Okay? Now, we're going to talk about a new type, periodic functions. A periodic function is a function where the graph has a repeating pattern, and we call these sinusoids. Okay? Now, the typical sinusoids we talk about are sine theta and cosine theta. Now, both of them have what we call an amplitude. Okay, the amplitude for both of them is 1, and that is the distance above or below the horizontal axis. Now, I want to clarify this as a center line because later we'll be changing where that is. Now, 1 is the standard amplitude for sine and cosine. We're going to look at graphs that have a different amplitude. Okay, the range, remember the all possible y values, the standard range for sine and cosine is -1 to 1. And the period is the length required to complete a full cycle. And it is 360 or 2 pi for both sine and cosine. Okay, now this, as all of our other things, come from the unit circle. So we're going to graph the standard sine and cosine. This is your x, this is your y. Okay, let's do y equals sine of theta first. Okay, now if this is 0, I'm going to graph it in degrees. We can also graph it in radians, but I'm going to do degrees because that's what we're most familiar with. Okay, so we have 0, 90, 180, 270, 360. My top is 1 and my bottom is -1. So at 0 degrees, sine is 0. Right? We know on our unit circle that the sine of 0 is 0. The sine of 90 is 1. The sine of 180 is 0. The sine of 270 is -1. And the sine of 360 is 0. So if we connect this graph, connect our dots, that is our sine function. Now, if I was to go in the negative direction, -90, excuse me, -90 would be here, and -180, I would go all the way up to 0. This is the sine function. Now, if we look at 0, 0 to 360, that is a full period, meaning we have our starting point, and we've gone all the way back to our starting point. Okay, let's look at cosine. All of these values I get from the unit circle. So we have 1, -1, 0, 90, 180, 270, 360, and let's do -90, -180. At 0, cosine is 1. 90 cosine is 0, 180 cosine is -1, 270 cosine is 0, and 360 cosine is 1. So we go down and look like this. And if I keep going, cosine would look like that. Okay, all the values came from the unit circle. It's very important why you know the unit circle. Now, the important thing to notice about sine is sine goes through the origin. Cosine does not. Okay, that is the big distinction we're going to make between sine and cosine. You need to memorize the sine and the cosine graphs exactly as I've done them, because we are going to be getting to later lessons where we're going to be doing a lot more with them, and we're going to be manipulating them a lot. Okay, we're going to do that a little bit today, but I'll show you how. So in the graphs of sine and cosine functions, if sine of theta or cosine of theta is multiplied by constant C, okay, actually let's call it B, that's what we'll call it later, B, okay, then the value of the function for any theta is multiplied by B. What does this mean? The amplitude becomes B instead of 1. So let me show you an example of that. So if you were given this graph, this is your y-axis, this is your x-axis or theta, okay? We have 0, 90, 180, 270, 360, 6, and negative 6. I'm going to go here, 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 here. All right. We want to write the equation for this sinusoid. So the first thing you have to do is identify, is this a sine graph or a cosine graph? Now it's going through the origin, so we know that this is going to be a sine graph. Now we look at the period, 0 to 360, that's the same, so we're good. Let's look at the amplitude. Instead of 1, we now have 6. So what I do, I think I wrote this a little too extravagantly. This is negative 6. What I do is I multiply my graph, my equation by 6. So this gets y equals 6 sine of theta. That is my graph. This is the equation of my graph. I don't do 12, the distance from the bottom to the top. I only do the distance from the middle line to the top, which is the same distance from the middle line to the bottom. All right, let's do another example. I want these graphs in your notes. So we're in radians, okay? If a question asks you to write an equation or it has something with degrees or radians, you always use what they give you. So in this example, they gave us degrees, so if we had to use anything in the function, we would use degrees. This equation gives us radians. If we had to use anything in the function, we'd use radians. Okay, so again, we first determine, is this a cosine graph or a sine graph? We're to write the equation. We don't go through the origin, so this tells me this is a cosine graph. Okay, now we look at our amplitude from our middle line up to 3, which means my amplitude is 3, so I multiply my equation by 3. However, we know if we look at our regular cosine, we start at positive, not negative. But in this one, we start at negative, which means we reflected over the x-axis. Now we should know what to do with reflections. I multiply my outside by a negative. So this is y equals negative 3 cosine of theta because I flipped over the x-axis. Okay? Cosine and sine functions are still the same as regular functions. You know, they have reflections and translations just like we normally would. So we still do the negative on the outside to flip over the x-axis, reflect over the x-axis. Like I said, you need to memorize your standard graph for sine and cosine because we're going to use it a lot this year. But for now, that is all. So have a good rest of your night.